Hi everyone. In this video I show you step-by-step how to build a Windows image for VPS deployment from the Microsoft Original ISOs. The build process occurs on DigitalOcean Droplet using QEMU. The method I am about to explain in this video should work with all versions of Windows should you have the appropriate license. However, I will be using just an evaluation version of Windows Server 2019 to demonstrate the process. If I first show you a quick overview of the process, that will give you a clearer understanding of how it all fits together in Step 1. In Step 1, I get a Ubuntu-based VPS from DigitalOcean. As it is one of the very few VPS providers that supports the installation of a virtualization product like VirtualBox or QEMU to install 64-bit Windows operating systems. In Step 2, I will show you the commands that I use to install the Linux lightweight XFCE desktop, an RDP-based remote control package, and the QEMU virtualization packages I will be using to build the Windows image. All from the Ubuntu repositories I had previously installed, and then used VirtualBox but found problems with some versions of Windows. So now have switched to use QEMU. In Step 3, I will connect to the Linux VPS desktop via RDP. So I can use its web browser to find and download both the version of Windows ISO I want and the required Windows Virt IO drivers that I need in Step 4. I'm going to start the QEMU virtualization program on the DigitalOcean VPS with the downloaded ISOs attached using only their provided web-based console, and transmit the Windows installation pictures using QEMU's built-in VNC server in Step 5. I'm going to connect to the VPS by using a simple VNC client so I can see the pictures it's transmitting, and then install Windows with the required Virt IO drivers. I will also configure it to allow remote control and harden. It's already significant security. The aim being when it's deployed later, it is both fully ready and well secured. In Step 6, I will zip up the Windows hard disk ready for deployment across the internet. In Step 7, although not really part of the build process, I will show you how it can be deployed to a VPS. There are a number of VPS providers that allow you to import a pre-existing Windows image, but it will depend both on your Windows license type and any agreement you have with the VPS provider. As each situation is specific to you, this video cannot cover that topic. Instead, it will focus on the mechanics involved and show you how you can deploy it. Now let's start. Step 1 was to get a new Ubuntu 24.10 VPS from DigitalOcean. So let's do that. There are a lot of different VPS providers that I have used over the years. But out the 12 or so that are on screen, I know Google Cloud instances can be altered to allow virtualization, but I have found them both expensive and slow out. The remaining 11, I am only aware of only one DigitalOcean that supports both installing and running a virtualization product that enables 64-bit operating systems. If you know of any other, please let me know in the comments in case you would like to follow along. To aid your understanding of the steps involved, I have put a link to the DigitalOcean website offers page, which with their current offer makes it free for new users to do so. However, as an existing user, I will simply log in regardless of whether you are an existing or new user. You will be taken to this page. I now create an Ubuntu 24.10 instance on which I will run the QEMU virtualization product, and so build the Windows machine. When it comes to picking an instance size, I need one with at least 4 GB of memory to run a virtualization product on, so I chose the $24 option. Don't worry though, it won't be expensive as I only need it for a few hours. Because after the video, I will save it as a cheap snapshot so I can always easily get it back. Then delete the VPS itself for authentication. I need to pick password authentication because I will need to log in via RDP later on. That only works with password login. I just ensure that it is at least 10 characters long, complex, and most importantly, not in a dictionary like the example on screen. So this Ubuntu server is not particularly susceptible to brute force attack. After creation, I go to the Droplet's main control panel. Step 2 was to install the XFCE desktop, the XRDP remote control packages, and QEMU, the virtualization software. So I will demonstrate that I open their web-based console. This first command, which like all commands are in the YouTube description, in case you are following along, it updates all repository indexes, then upgrades all packages on this server to their latest versions to ensure they include all known bug fixes and security patches. This second command installs the XFCE lightweight desktop, the Firefox web browser, the XRDP remote control package, and finally Gzip, which I will be using later. I now install the various QEMU virtualization packages that I need. Finally, I put a small hidden file under the home directory. So the system knows for this user that it should start the XFCE graphical desktop when I log in via RDP to ensure all packages are running in the correct dependency order. The easy way, I just reboot. Step 3 was to connect via RDP and download both the Windows and VirtIO drivers. So I will demonstrate that I start the remote desktop connection software that comes pre-installed on all Windows PCs. I enter the Droplet's IP address off the DigitalOcean website and the user route. On the Local Resources tab, I ensure only clipboard is checked. Before connecting, I check the box to allow me to save credentials. When prompted, I can paste in the complex password. The desktop may take 10 to 15 seconds to appear as this is the very first time I have connected to it. I open a web browser. Again, this may take 10 or 15 seconds this first time, which feels like an eternity, but I just give it time rather than use a specific web address for any ISO as they keep moving location. I enter into Google the words Windows, download VirtIO drivers to find them and follow the web links that appear on screen. I then download the latest stable version of the drivers. I now key the words Windows ISO download, and in this case, add Server 2019 into Google search. After a couple of web pages, I am asked to complete a form. However, as I have already done so only 5 minutes ago when testing the steps in this video, it just starts downloading. When finished downloading, I fill in a copy of the template QEMU command, which you will also find in the YouTube description with the names of the downloaded ISO files as I'm going to run it in a minute. I then just reboot to ensure all memory that is used by this desktop and web browser is freed up and so available to QEMU. In the next step, Step 4 was to using the web-based console to start the Windows install process within a QEMU virtual machine. So I will demonstrate that back in the DigitalOcean control panel. For this droplet, I open the console. This first command, again from the YouTube description, creates an empty 24 GB hard drive. The reason it's as big as 24 GB is as I found some versions of Windows can take almost 20 GB of space before the 2 or 3 GB swap file they write out as well. Therefore, I found out when researching this video that it's best to allocate this size to start with. Before copying and running the main QEMU command where I filled in the ISO names too in the previous step, I will quickly explain this command further. It is asking for 3000 megabytes of memory. The CPU it is asked to emulate will just be whatever the host machine is. It enables KVM, which increases speed dramatically. That is the kernel-based virtualization technology that most Linux machines have nowadays. It is told to boot from the Windows ISO and not the empty hard disk. The USB tablet command just tells it to follow my local Windows machine's mouse accurately. It is asked to use the file I just created as the machine hard disk, and to treat it as a virt.io device. I then specify where it can find the Windows ISO I downloaded earlier, and then the virt.io Windows drivers. Finally, it's asked to transmit any resultant graphical pictures using its built-in VNC server on display number 55555. Most people specify display number 0. As the VNC server adds 5900 to the display number, it therefore transmits over the default VNC port of 5900, but if found by an internet-based bot, it will be attacked automatically, and by using the default port of 5900, this will happen in seconds. By specifying display number 55555, it transmits pictures over 5900 plus 5555, meaning port number 61455. The use of this random high port number significantly reduces such attacks in testing. I had no attacks on that port at all. For the full 6 hours the test ran. I now copy the command, then run it.
Step 5 was to install and then configure Windows using a VNC viewer. So I download the real VNC viewer, importantly from the official real VNC, and install it on my local Windows PC once it has been started. I copy in the IP address of my DigitalOcean Droplet, followed by a colon, and then the port number. It should listen for VNC pictures on, which in this case is number 61455. It then connects to the VNC pictures. The QEMU virtual machine is transmitting. I will fast forward bits of the install process. I have paused here to explain. There are 5 virt.io drivers I need to load at this point, so although not all presently used. When the machine has been moved and is booting up on a new provider's VPS, it needs access to these 5 virt.io drivers out of its built-in driver store. The 5 drivers I need are shown on screen, which I will now install. At this point on some versions of Windows, it may ask what type of account it should set up. If it does, I would need to select a local or domain account here rather than a Microsoft account, as that user ID will be part of this Windows image. However, it does not in this version of Windows and just indicates its default user ID is already a local account called administrator, so I just provide a password here. As this is VMC out of the box, cut and paste doesn't work, so I have to key the complex password. Now I am on the desktop. There are a number of configuration changes that I need to make, a list of which are on screen now. The first thing I need to enable is to allow remote desktop or RDP connection to this machine. The second thing I need to do is to change the default RDP port. This machine is using for RDP from 3389 to something random and over 15000. In this case, I use 19529. When I left it at the default of 3389, I could see 1400 logon attempts, probably by internet bots, in a 6-hour period following the change to just use port 19529. That dropped to 1 in 6 hours. The third change I make is to only allow access to this machine via port 19529 by creating a rule allowing such after I have disabled all other ports allowed through the firewall. Again, to improve security, I renamed the default administrator account that internet bots know about an attack to a name like WinAdmin that they don't know about, and so don't attack it. I now reboot to make sure the new account is fully in use. Otherwise, various errors are reported.
I now run Windows Update to close any known vulnerabilities in Windows since this version was first issued in some versions of Windows like Server 2016. This updates Remote Desktop Services or RDP to close some found vulnerability, and the desktop Windows client, which I will be using later, won't even connect to this VPS unless it detects its RDP service has been patched. When all updates have been installed, I restart. Finally, I log on and clean up the C drive. So before deployment across the internet, the image is as small as possible. And when finished, as all configuration has now been applied to this machine, I shut it down cleanly. Step 6 was to zip up the Windows hard disk. We just built in QEMU, so I will demonstrate that. Like I did in the last step, I will be using the web-based console for these commands. I first list out all the files and confirm I can see the file hard disk raw. I then use the Linux df command to show the disk free space. To prove I still have, say, 10 gigabytes of free disk space to hold the resultant compressed file. I then copy the gzip command out of the YouTube description and fill in the bracketed bit with the name. I wish to call the output file and then run it. I list out the files again, and as I can see the gz file I have just produced successfully. I remove the raw hard disk. Then finally, although not really necessary, I reboot to ensure all traces of QEMU is removed from memory and to provide a nice clean start. Now we have finished building the Windows image, although not the main part of this video. I will, however, demonstrate how I can deploy it to a PS provider. I just remind you at this point, what you can do will very much depend on the license and agreements you have, but as that is beyond the scope of this video, I am just going to focus on the deployment process. Now we have finished building the Windows image, although not the main part of this video. I will, however, demonstrate how I can deploy it to a PS provider. I just remind you at this point, what you can do will very much depend on the license and agreements you have, but as that is beyond the scope of this video, I am just going to focus on the deployment process. The first step is to start the recipient VPS in rescue mode, which ensures that the VPS's hard disk is not used by the boot process, and so no file on it is locked or in use, meaning it is available to receive the Windows image. The first command I run is the link xcommand ls block, which lists out all available block devices that this rescue image can see and determine how it refers to the machine's hard disk. This is usually something like SDA or VDA, and in this case I can see it's the former. I now type out the main deployment command, then insert the specific values that I need for this deployment. Firstly, the hard disk reference it needs to use, followed by the name of the gz filelet, and finally the IP address of the DigitalOcean Droplet that it should connect. That is holding the gz file as I'm getting the file from my own DigitalOcean Droplet. I use the SSH command when run. It will first ask me if I'm sure I want to connect to the DigitalOcean Droplet, which I do, and then I ask for the root user's password on the droplet so it can connect after a couple of attempts. I finally get the password right and it starts to write out the image to this machine's hard disk. After it's finished for this VPS provider, I just reboot and it will boot up from the hard disk. Other VPS providers can be more specific and may require me to say in their VPS control panel how the instance should boot. After a few seconds, the Windows image is up and running on the VPS. There may be some changes, for example, expanding disk space that I need to do. So the 24 GB disk image is expanded to use all the hard disk space on this VPS. but those are beyond the scope of this video. Thanks for watching.